a video for you here. So let's just review the question real quick, and then I'll show you how to use Desmos. So it says, your math class is picking up litter each weekend in a local park. Each weekend there's roughly the same amount of litter, right? So the same job size. The table shows the number of students who worked at the first 4 weeks of the project and the time they needed. So we had in week 1, 3 students and it took them 85 minutes, 5 students and it took them 51 minutes, 12 students and it took 21 minutes, 17 students and it took them 15 minutes. And the idea here is that more students, less time, but we could assume that no matter how many students there are, they're still going to take some time to pick it up. So we're trying to model the data. We can't use our calculator. So if you go to desmos.com, you'll come up with a calculator. What we want to do is we want to add this data table in here. So we go to this little plus sign, and you can click on table. All right, and then we're going to say 3, 5, 12, 17, all our x values, right? That was the number of students. And now we have our y values. We have 85, 51, 21, and 15. And if we look over here, we're like, oh man, we don't see anything. Well, that's because our data, our y values, are not going up high enough. So if you see this little wrench up here in the corner, this wrench will let you change the scale. Now, for our x value, right, we have 3 to 17. So let's leave some negative, but we need to go up to at least 20 on the x value. And so now we have, let's say we're counting by 2's. All right, and then we have over here, we have y. We don't have any y values, but let's still give it a little bit negative so we don't square it off. And we want to go up to at least 85, our highest, but let's just go a little higher. And we're going to step by 10. Step is just here. These are step 10, 20, right? And then I can click off of that, and now I can see these data points. And what we're trying to do is we're trying to think of a model. We're working with indirect variation right here. So what's cool about Desmos is it'll create a model that goes through those points best, but you have to know how to enter it in here. So if I type in, and my data, by the way, is x1, y1. So we want y1, right? We have these y1 data points, and it's, you can see it's automatically taking this list and putting it in here. On your keyboard, there is a little squiggly line. Oh, let me see if I can even show it to you here. No, this only gives me numbers, so I have to type it. Where? So my squiggly line is right next to my Z button. So I want this, I don't want that button, but if I hold the shift key, I get this little squiggly line. And this is saying that it's going to take this Y data and it's going to try to fit it into whatever model I want. So, you know, like if you remember that a straight line is mx plus b, and it would fit it in there, right? That's a straight line, but we can see that doesn't go through the data well at all, so we don't like that. All right, so we're working with indirect variation. So indirect variation was y equals some value of k divided by those x1 values. And you can see here the calculator, don't worry so much about these other things. The calculator gives you the value of k down here. And that means that our function is, I'm going to just write it down here so we have it, y equals, this is our function, right? Y equals 254.871 divided by x. And then again, it overlapped that again, right? I just took that function. So what does this mean? Well, we have to remember that y, let's go back over here, y was the time and x was the number of students. So our model, right, and look, we're just saying 255 because it's really close, right? That this value up here on the top is about 255. So now we have a model that says, and this is just, see, they were using n and t's instead of x's and y's, so it makes it a little bit confusing. But if we take, let's go back over here to Desmos, if we say we're going to have x times y equals 255, well, again, we get the same thing. They were using n and t's. I can't make Desmos use n and t's. So now we want to know, well, how many weeks should there be to complete the project in at most 30 minutes. So let's take this over here so we can type on it a little bit. I can't type on that screen. File, let's do new one of these. Let's make this be blank. That's not what I wanted to do. I want to be able to drag. So we had a model that said the number of students times the time equaled 255. We rounded it, right? So number of students times the time equals 255. And now they're asking us, well, and how many students? So we don't know this part, but we know this part. So we're going to just substitute in here. We don't know how many students, so let's just leave that n. N times 30, right, is going to equal 255. So that, oh, not n. Yeah, the number of students times time. So our number of students has to equal 255 divided by 30. All right, let's use a calculator here. It's early. 255 divided by 30 is 8.5. Well, we got this issue. It's kind of impossible to have 8.5 students, so we better put 9, because if we don't, we're not going to have enough. All right, so if you want to, anytime you want to use Desmos, you put in your data. And then you always have to think about, well, what kind of regression am I doing? I'm doing this kind of regression. All right, and then it's going to give me a model. It's going to tell me the value of k, and I can work backwards to solve it.